Good afternoon, everyone, and welcome to another session of AI for Growth. This time we're focusing on the manufacturing industry with a little accent on the textile industry. We have 5 interesting presentations for you today. The first one will be brought by Transition, who will be talking about the trends and evolutions of AI in the manufacturing industry. After that, we'll have a presentation by Delaware, who will be discussing their application in smart image tagging through the tagging factory. After that, Ordina will give us their presentation on the bill of materials matchmakers, again in the textile industry. After these 2 industry cases, we have 2 academic presenters who will be presenting some of their assets that have been building up in the academic world for use in the manufacturing industry. The first of these is by the IPI research unit, talking about vision in the loop, or real-time monitoring and control in additive manufacturing. And finally, we will have somebody from the Sumo Research Lab who will be talking about data-efficient machine learning for engineering design. And now, without any further ado, let me introduce Vincent Dafour from Transition. Vincent, the floor is yours.
Thank you, Michael. Thank you for introducing me. Also, thank you, AI for Growth, for having me. To give you a short intro, who am I? I'm Vincent. I'm CEO and co-founder of Transition. Transition is a startup. We're a 1-year-old startup. We're based in Ghent. And Transition basically stands for Trends in Transitie. We're an AI-driven and B2B data analytics company. And what we do is we focus on monitoring, analyzing, and predicting trends. Which kind of trends? All trends that impact companies. So you can think of ourselves as a personal virtual assistant that can answer questions like which trends are impacting your company, which trends are impacting your customers, how hard are these trends impacting you, how and when should you respond, and so on. So with this, we really try to help organizations become future-proof in this fast-changing, unpredictable world. And we do that in a data-driven way. So we use open big data. We have our own proprietary trend analytics algorithms, and we use AI to be able to monitor trends impacting a certain environment. And these environments can be sectors, so we're not linked to any sector. We can show what's going on in any sector, whether it's manufacturing, banking, retail. And the cool thing is that we can spot spillover effects. So things that are happening, for instance, in retail might be interesting for banking, might be interesting for manufacturing. And that's because we're data-driven. We can really tailor these insights and also look what's going on in other sectors. So we've basically productized our algorithms. We've automated trend watching. We're building technology that can continuously monitor the future of companies. A couple of added value features are that we can indeed continuously do trend monitoring, that you can build your own tailored reports, that we can create an actionable warning system where we proactively warn you when things start to change in your environment, that we can really profoundly show you a lot of trend insights. We can show you trend news, trend cases, and have a couple of collaboration features built in. So for this session, what we've done is we've looked at manufacturing, we've looked at a couple of most impactful trends within manufacturing, and we've selected 40 of them. And the 40 trends we've built into a mini report. I'm going to show you after this slide. And what's interesting is that we've looked at a couple of megatrends. So big trend themes that don't tend to evolve that fast. We're going to look at one megatrend, basically digital transformation and the impact on manufacturing operations processes. We're going to look at technology trends which are used in this digital transformation. And then we're going to zoom in on one technology trend, mainly AI, and look at what's going on there from a trend perspective. So let me now just move you to the reports. So this is the report that we usually build. What you see here is a trend radar. So 40 trends clustered together. And what you see is from a high impact perspective, so AI, all the way down to a low impact for the printing on a specific context, in this case, manufacturing. And we can really show different dynamics. For instance, there's also the manufacturing textile industry in the report. If I would zoom in on that, you see that the dynamics of how these trends impact that context are different. So let me just go back to manufacturing and then zoom in on the mega trends that are in this report. So we've selected 6 because we saw a lot of trend strengths in these sectors. So if you look at it within manufacturing, number 1 trend from a mega trend perspective is sustainability, followed closely by digitalization and digital transformation, personalization and customization. So that really is a consumer behavior change towards more personalized products, personalized services. Urbanization, so the rise of cities, globalization, and resource depletion. Now, what's interesting is if you, for instance, take another view on this, not showing you the impact on the sector, but how fast these trends are changing, there is one that's basically changing rather fast, and that's digitization and digital transformation. So let me just click on that one to give you an example of the things that we can show on a trend level. So first things, what we do is we quantify it. So we look into the past, 7 years into the past, and we visualize how these trends evolve through time. And we do that with a certain focus on the sector. So what you see here is the impact on the manufacturing sector, and we compare it to, we basically compare it to anything, but in this case, it's compared to all industries combined. So that's the green one. The blue one is the impact on the manufacturing sector, and the grayed out zones is a fault tolerance that is built into our models. So as you can see here, indeed, digital transformation has really picked up within this industry, also within all industries, the last couple of years. And our models forecast that this growth will linearly evolve a little bit through time. So this is like the chart evolution that we can show. A next thing is that we can show an actionable suggestion. So what should you do as a company with this trend? In this case, it tells you to incorporate this trend. That means really scale digital transformation within the organization. We also derive a couple of KPIs or metrics based on this. For instance, we predict on a time horizon perspective when these trends will hit you the most. So in this case, 0 to 2 years, which means that you should indeed be doing something with this trend. And we can show you a couple of other KPIs like the trend strength, the average trend strength of the last 24 months, monthly rate of change for the last 2 years, monthly rate of change for the last 7 years. So the 2 years is really interesting to spot whenever trends start to picking up speed and accelerating really fast. So this is like the quantifiable high-level view on what we can do on a trend level. And then we can source a lot of metadata behind these trends evolutions. For instance, what other trends do we find a lot of signals for digital transformation? Cloud computing, cybersecurity, remote workforce is probably due to COVID that we see the signal appearing, and a couple of others. We can also zoom in on where do we see which industries are most impacted by this trend. In this case, it's retail, banking, telecom, also VC, which means VC is basically investing in these kind of technologies, and a couple of others. Now, because we use open big data, so we basically monitor the internet, we can also show the stories behind the data, basically. And we can really tailor these feeds based on whatever preferences you might have. So this is how we look at trends from a quantifiable and AI-driven approach. So as you can see, digital transformation, fast growth, high impact on the manufacturing sector. Now, let me zoom in on purely some operational manufacturing activities from a trend perspective. So which trends are impacted by digital transformation on an operational level? And then you can see that, for instance, of course, innovation is a big one, but also process automation shows high strengths within the sector, followed closely by quality control, predictive maintenance, anomaly detection, quality assurance, and so on and so on. Now, again, the cool thing is, if you would look at it from a changing perspective, that there are a couple of these trends that tend to be changing rather fast within manufacturing. Predictive maintenance, demand forecasting, and let me zoom in on process automation because I know there's a case coming on intelligent automation. So what you see here on process automation is that the trend is indeed also picking up speed, but more in a linear way. So not as exponential as we saw for digital transformation, but our models predict that this trend will evolve rather linearly into the future. That's why we see that most companies are indeed looking into process automation already, or are starting to look into prototyping these kind of solutions. So I don't have the time to zoom in on all of them, but of course, this report will be made available to the ones who are interested afterwards. So if we now look into, we have digital transformation having an effect on operational manufacturing processes. Which technologies are mostly used in these transformations? Then you clearly see that AI is like the top trend that has an impact on these operational activities, followed by robotics, IoT, cloud computing, 3D printing, blockchain, autonomous vehicles, and so on. So these were selected by us because we saw there was a high impact on these sectors. Again, if I would look at the change of speed of change, then you see that there are two really kicking out. It's AI and distributed ledger. And for the sake of it, let's zoom in on the AI trend. And again, what we will see for this trend, that it has grown rather fast the last couple of years. And since 2017, our signals are at the top level. So that means that how we normalize these models, that it really keeps trending on the last couple of years within manufacturing. If you look at related trends, it's deep learning, NLP, autonomous vehicles, chatbots, algorithms as a service, a really interesting one, intelligent virtual assistants, and so on. So again, a trend that sees high traction, high trend strength within the manufacturing sector. So now let's zoom in on within AI. Of course, there are like a couple of sub trends that are going on. So what we've done is we've looked at a couple of specific AI trends and a couple of technologies that use AI to be able to transform these processes. And as you can see, again, from an impact, you see that machine learning is mostly trending, followed closely by computer vision. And I think we have a couple of cases that have to do with these trends. Also NLP, robotic process automation, intelligent virtual assistants, intelligent automation are really trends that are having an impact. And when I apply the same approach, so let's look at change now. There's something peculiar, because what you see here is that we see three trends. That's artificial emotional intelligence, ethical AI, and trust in AI. And when you look at it from a strength perspective, these are like the ones at the bottom line here. But if you look at it from a change perspective, they're not having that much impact today on the sector, but they're really accelerating fast. For instance, if I would zoom in on this one, explainable AI, we would see a growth going on here. So basically a trend that didn't exist before, and since 2016, 2017, it's really accelerating. And that's due to because whenever we apply more AI in companies, we need next level AI, like explainable AI, trust in AI, emotional AI. That are the next gen trends when it comes to AI. And let me zoom in on one more just to round it up. Let's look at intelligent automation, again, because there's a case coming on intelligent automation. It's also a trend that is growing fast in the sector. It's also from basically nowhere in 2012, 2013 to already some strength, and it's growing kind of linearly. So really interesting to see that we have some cases now within this session and where we can spot the trends that this is really having an impact on the manufacturing sector. So thank you for having me, and I wish you all a nice session.
Hi, Vincent. Thank you for that wonderful overview. I'm happy to see that artificial intelligence has been trending in the manufacturing industry. It seems we're coming at the right time then. Lovely interface to the tool as well. And I especially liked the fact that you were able to show the difference between trends that are currently small but are picking up in velocity. So the 2-year, 7-year difference, or the green colors for the people with a more visual memory. So that's a nice addition to the tool, I find. I have a small question. How do you make the distinction between buzzword trends and trends that are already being translated in revenue impact or things like that?
Mm-hmm. Well, that's basically the added value of applying AI, natural language processing, onto huge volumes of worldwide data. Because we as persons are usually biased whenever we see things appearing in the news or in the media, and we start to reflect like, okay, this is really impacting us as a company. But in reality, what's happening is that you're in your information bubble and you see a couple of signals appearing where you think, okay, this is huge. But with AI, with big data, what you see is these signals tend to average out on a global scale. So these buzzwords, apply the right natural language processing methodologies to it, you can really see that these are things that are buzzing in a certain region or a certain sector, but that they're not being growing or impacting an industry or more industries in the field. And what we basically do is with NLP, we look at this innovation view. So whenever we start to see or VC capital, whenever we start to see new products, new services in the market, whenever we start to see business models appearing that are using this technology, that triggers our signals to saying, okay, this is not a hype anymore. There's actually a business behind it, and it's really augmenting within a certain sector. And that's basically how we look at it. So not only at the signals, but going a little bit further and really looking at it from a business innovation perspective.
Okay, it's a very convincing answer. I'm happy to hear you say that. One more follow-up question, because you've been digging deeper. We've been looking at the data, so to say. Of course, a lot of times when you're doing and building an AI application or any type of application these days, you have to have the right data. Now, especially in your case, when you're building a tool to basically sift through, well, inhuman amounts of data, how do you do quality testing? How are you sure that whatever comes out corresponds to something? Because it's not like you can make the same report by hand and use that as a ground truth. So how have you addressed this problem?
Well, yeah. Since the beginning, we know we don't want garbage in our data because that will affect our algorithms and garbage in, garbage out a bit. So what we basically do is we don't buy data sources. We're not against it, but we've tried it and we see that the quality of these labeled data sources isn't what we want it to be. So what we do is, and we spend a lot of time and effort in it, is that we scan our own data sources. We do our own quality checks in terms of, is it fake news? Is it copyable news? What's the quality of this news source? And then we do our own labeling of these data sources. So we know that the data sets that we're working on is really the quality level that we want it to be, because otherwise we can't stand behind our predictions if we know that the data that we put in isn't just the level of quality that we need. So that's a little bit different than other companies who buy huge amounts of data, but they use that. We don't do that. We tend to really curate our data sources on our own and know that the level of quality is top. So that's how we do it. Yeah.
Okay, I think we should end this here. But thank you for your overview. Bye.
Indeed. Bye.
Welcome back. We now will have our first pre-submitted little video around smart image tagging through the tagging factory. I have here Kevin de Beck from Delaware, but let's first watch the movie.
Hello, my name is Kevin de Beck of Delaware, and in the next 2 minutes I want to introduce the tagging factory. So the idea of the tagging factory originates from some R&D research which we did at Balta. And Balta told us that they were spending quite a lot of manual time labeling their product images. And it turns out that not only Balta was having issues with this process, but many of our clients were running into similar troubles. So we decided to provide them with a solution which we call the tagging factory. And the tagging factory is an AI-driven automated image tagging or image labeling process. So the main benefits of using the tagging factory are, first of all, it's fully automated. So you save time because otherwise you would manually do the labeling. Second is because it's automated and AI-based, you improve the label quality, but also remove any inconsistencies because of human bias. And third is that you can easily expand the number of tags that are available and also include specific custom tags to the model as well. So focusing a little bit on the background, how is it or what is it made of? Well, the tagging factory is a combination of computer vision models where you have some pre-trained, ready-to-use out-of-the-box models, but they are also been extended with some custom-developed code and the custom-developed AI models developed by Delaware, which allow you to include some custom tags as well. So as a default, we have over 100,000 tags available. And like I mentioned before, there is the opportunity to include very niche, very case-specific tags or labels in the model as well. How can you use it? Well, it is fully cloud-based, so it is API accessible, where you send your image to the API, and then the API returns the number of tags that are related to that specific image. It is based on some state-of-the-art technology of Microsoft, Google, etc., expanded with the custom-developed models by Delaware. And we can use it as a one-off quick scan where you would review a number of images, but it is also available as a service where you daily, weekly, monthly re-evaluate your image labeling. If you look at the future, well, as like I mentioned at the beginning, it started in Balta or in the textile industry, but we are noticing quite a lot of other industries or new markets that have interest or specific use cases for the tagging factory as well. Thinking about product information management systems, digital assets systems, where labeling play an important role, but also in e-commerce and web shops, adding an increased amount of image labels can improve the search result as well. And last but not least, we continues to improve our models, including the amounts of labels that are available as well.
So, Gavin, thanks for submitting this recording in advance, and thanks for being here.
Good morning. So my name is Kevin de Beck. I'm working as a data scientist at Delaware, and I'm specialized in applying data and artificial intelligence in sales and marketing applications. So everything going from churn prediction, customer segmentations, product recommendations, all that sort of stuff. Okay. And the tagging factory is a little bit different in that area. It's still related to customers, but it's mainly focusing on products. So we developed a solution that combines a number of computer vision models that allows you to label or to automate your labeling process of your images. And this is often used in products because you produce a product and then you want to sell it or add it in an online B2B portal, for instance. And in order to make your product searchable, you need to label the products, so describe how the products look. And then the better you label it, the easier it is to find your product. For instance, if you were looking for a black t-shirt, then you would, as a customer, search for black t-shirt, and then you expect to see all of the black t-shirts popping up, so you would need a label to that image describing it's a black t-shirt on the image. So that's what the tagging factory does.
Okay, so in that sense, you're not building solution to label t-shirts, you're building an entire pipeline to allow your customer to handle every aspect of the image labeling problem.
Indeed, it's the core of the tagging factory is a number of generic applications, so generic models that offer, I think at the moment it's over 100,000 different labels that the tagging factory can out of the box identify. So whether it's t-shirts or flowers or carpets, it doesn't really matter. You give your images to the tagging factory, and then you receive a number of labels that you see based on or what the tagging factory sees based on the image. But also you have the option to add your own labels as well. So it's a combination of out of the box, but also some generic component or some custom components. So if you have specific needs in terms of customers that require very specific labels that aren't really available in the generic part, then we can add our own custom models as well. So to really specify that need, for that we need to train the model a little bit. So we need some historical data, some images that already are having that label manually added to it. But based on that, we can add custom labels as well.
Okay, so it's kind of a bootstrapping where you start with a small sample.
Yeah, exactly.
Yeah, all right. No, that's a fascinating development. It probably scales much better with the demand from client side to develop this kind of product than one where you have to put a data scientist to tag all the images or to formulate the models on a case-by-case basis. Yeah,
typically there are already a lot of historical images labeled which we can use, so we can one-on-one add it to the model.
How long has the tagging factory been around?
I believe it's the first idea came, I think it was 2 years ago. Or maybe even a little bit longer, where we had a customer that was talking about image labeling and where the whole process was being done manually. And that customer had a product or a production cycle where every quarter over 5,000 new products were released, so different variations. And then you had a volunteer within the company that had to label every quarter these images. So as you can imagine, it's very boring. So that was the conversation starter, and then we noticed that there were some other applications for other customers as well.
I must imagine that after a couple of seasons they run out of volunteers for something like
exactly.
that. Would you say that the tagging factory was a new kind of product to be built for Delaware?
Well, we do have some previous experience in working with labeling and computer vision, but really focusing on a more productized service. That was new for us.
And has this influenced the kind of profiles that you were looking for within Delaware?
Well, the one of the main benefits for such solution within Delaware is we're a quite large IT consulting company, so we have a lot of different experiences within or different profiles within the company. So we combined a number of different teams together in order to develop it. So it wasn't really attracting new profiles, but it resulted in some new collaborations within the company itself.
Are you now a little sub-company within the company almost, or
wouldn't call it a sub-company, but there's definitely a number or a group of people that are related to the tagging factory, and it's spreading slowly but at a steady rate.
Okay, are there any other interesting developments in the same field or within Delaware that you'd like to talk about?
Well, in terms of the image labeling and the computer vision part, we do see, well, like I mentioned, it started with the product, like really in a manufacturing context, but we see different needs coming from different areas as well. Like for instance, customers where we built a web shop and we want to optimize the search on their web shop so that the product search matches better to the product offering. That's also a solution where a similar case with image labeling can play an important role. And also in the area of digital asset management and product information management, where you have a large library of over sometimes 1 million digital assets. That's also something where computer vision and more or less the tagging factory can help out as well by labeling all these assets fully automated, so no human labor there, and then making it searchable or improving the search functions in those tools as well.
Okay, and you mentioned in the beginning the importance of having a label. If I want to find a black t-shirt, I need to, of course, be able to look for a black t-shirt. Are you closing the loop with seeing, okay, which labels now work, which labels are important and which not, and does that lead to feedback in the system?
Yeah, that's the interesting part, because the tagging factory itself doesn't really solve the problem, or isn't really a predictive model. It's more a solution that generates new data, because you generate these labels, and these labels are new information that you add. So you can do all sorts of creative and interesting stuff with this new information. And one of the things is indeed afterwards analyzing, okay, which labels or which search terms are used quite often and how was the matching done. So to first of all analyze, okay, what's popular, but also to evaluate, for instance, on a web shop, which searches didn't show up a relevant product, so that you get information about possible gaps within your product offering as well.
And is this then something that is done by the client themselves, to the people using the tagging factory, to keep track of this, or do you work with service contracts afterwards to offer these supplemental services? How does that work?
That depends case on case. We guide them, and we provide some inspiration on how you can use this new information within the company, and then it depends case by case whether or not they start with it their own, or we guide them throughout the process and the system in the analysis as well. So we can offer this as a service. It really depends on the context.
Okay, and I guess a final question in light of time. Now that the tagging factory is active at certain of your clients, do you see that this lowers the barrier to additional AI services applications?
Yeah, that's definitely something, regardless of the tagging factory, that we notice that from there's a really big gap to take that first step, do that first analysis in terms of data or AI. But once you get the ball rolling, then you start a discussion and you start seeing different opportunities, or the customer says, oh, we have that problem as well, couldn't AI or data solve that as well? So that's definitely a positive side effect of the tagging factory, but also other solutions that we have, that once you start with that, maybe low entry, then you get you get to talk to the people on the field, and you spot some new opportunities for future AI as well.
Okay, thank you.
Thank you very much.
Welcome back to our next use case. We have two people from Ordina here today, one online and one pre-recorded, and one next to me. Jonas is here, his colleague could not make it today. We will first watch the movie his colleague submitted around the bill of materials matchmaker. So let's go.
Hello everyone, I'm Reinoud and I'm here to introduce you the BOM Matchmaker. As the name already tells you, it is a very exciting project. We are developing this project at a sports manufacturing company. There we are looking to extract information out of a bill of material in an automatic way. So I'm Reinoud, I work already 3 years for Ordina and I'm very excited to introduce you this project. First of all, I'm going to guide you through to the process we are trying to automate. At our customer, we have a customs department. Customs is responsible for the paperwork that is related to the import and export of the goods. They are also responsible for tax regulations. Taxes are determined based on the type of the good, the clothing in our case. Based on certain attributes, different taxes need to be paid for import and export of the goods. Attributes can be the type of clothing, the color of the clothing, but also more exotic attributes like the length of the cuffs or whether or not zipper is available, or the location of a pocket. Customs will look up information for this classification in the BOM data. The BOM data is unstructured text data. This is being filled in by product developers. It can be very messy and not really coherent. It also serves for different purposes, which is where customs is only one of them. So currently at our customer, we automated the workflow of a customs agent end-to-end. We did this in cooperation with RPA, which is the Robotic Process Automation Department. RPA will start from an article list. This is all the articles that need to be classified. One by one, it will download the product owner sheets. This is our BOM data. This will be given to a Python script, and the Python script will output a CSV file. This CSV file contains all the information that needs to be entered into the SAP system. Then the SAP system connects with other tools and serves as input for the douane and the taxes regulations. So this will be done sequentially, one article at a time. The Python script itself makes use of NLP techniques like bag of words and n-grams. It also makes use of mapping resources, of templates in Excel, or of regular expressions. However, so this is in place for shirts, shorts, and pants. This saves already 1 FTE at our customer. However, the project is not finished yet, and the long-term vision of the project is to incorporate other garments as well, like jackets and polos. For these other garments, images are being used by customs. Customs will look up, like I mentioned, all different kinds of attributes, for example, where a pocket is located. So it will be looked into different image recognition techniques to find these attributes on images. It will also be looked into ways of deploying this solution as an API. So this is the long-term vision for the BOM matchmaker. So as a last slide, I wanted to show you the birth certificate of this project, which is called Miss Classy. So this was my presentation. If you have any questions about this, please reach out on the email below. Thank you and have a nice day. Bye.
So Jonas, thank your colleague for his submission. Sorry you couldn't be here today, but we're happy to have you instead. You let me know that you are working on street litter detection problem at the moment. Could you tell us a bit more about that and about yourself?
Yes, I'm Jonas. I work for 6 months for Dina. There I've touched upon computer vision problems like now the litter case. Let me tell you more about the litter case specifically. So it is a project for OVAM. They try to monitor the litter evolution in Flanders. How they do it now, they go manually to a specific location, and there they start counting, okay, there are so many cigarettes, so many cans, and so on. So it is very manual labor, something that's where the costs incur, so they can really try to, if they came to us to really try to automate the system with AI, whether it is possible. So the first part was about a feasibility study. We first had to look into, is it really possible? How much data do we gather? And also a financial study that we could actually be sure that the AI system is cheaper than a manual solution. And now we are building a POC to see whether an AI solution works. So a first initial measurement of 2 fractions or something, and we try to build a model as good as possible to capture those in the street.
Okay, I understand that you probably also have you no longer have the bias of the data collection by automating it. It allows you to have a more accurate picture of the whole street rather than just the worst cases that somebody called you guys to say, hey, there's a litter problem going on here. I guess that's an added value as well.
Indeed.
But when I hear you talk about image collection out on the street, I think about privacy. How does that influence your case?
Privacy, it is a real issue. At first, we didn't think it was that kind of a big deal, as our cameras were pointed towards the ground. So we didn't think, okay, we don't capture any faces. Is it really a problem? But then the legal department came to us and say, yeah, even if you capture a leg with a tattoo on it, they can trace which person it is. So it really was a problem. So also the same with license plates, of course. We all need to blur it. So when we capture the data, we first need to run it through to a model, see that all the sensitive stuff is blurred, and then we can store it into a database.
All right, so you have to solve one problem before starting on your real.
Indeed, yeah.
And what were the expectations of the client in the bill of materials? We saw it working through a smaller scale pilot towards evolving towards a more service API oriented architecture. How has the process been with OVAM collaboration? What did they start out with? Demands from the client.
Really, they came to us and they said, yeah, we want to identify 27 different amounts of litter, and we told them, yeah, let's first try 2. Let's first try that this works, because you can spend so much money on development and you don't even know whether it's possible. So we decided to pick one difficult and one very slightly easier case, and then we can say, okay, this took around this budget, so it took so long, you need to allocate this budget, and then we can say, okay, if you want to do this for 27 frictions, then you need to allocate this type of budget, and then they will see, okay, with this amount of budget, you can attain these results. So the companies do not really think about the differences between a POC and development and production itself. So that's they need to think about it in advance.
I guess it's normal. It is not their core expertise, but it is ours. So the message to the companies listening here is involve companies such as Ordina early enough in the decision process, you would say.
Yes.
Yeah. And I don't know how much you know about the bill of materials problem, but could you say something about the way it evolved there? Did it start in the same way? How much was the problem scoped before you guys started working on it?
Yeah, I haven't worked on the case, so I only know it high level. So I can tell you what the project is all about, but they were already told it in the video itself. But I don't know the technical details, so I don't know the involvement of that. So.
Okay. Then more in general, once you deploy a solution, there often also needs to be maintained, or it can go through several different iterations. Is this something that is brought up by the client ever in your experience, or is it something that you guys have to also inform the client on the difficulties in maintaining a solution and so on?
Yeah, it's really up to us. Like I said, they come to us with a whole different with the end solution, and we need to decompose it into different problems. First start at the beginning, then go to the end. Maybe it is at the end, really in production, that it is needed to build an API or something, because it's really flexible for a specific company when they can choose later, okay, where will we deploy this kind of code? And so we build an API around it, we give it to them, and then can choose where to deploy the code. So yeah.
Okay, so that then possibly is an after service contract or stuff like that. That then remains to be discussed.
Yes.
Okay, let me see what else I had. In general, talking about the OVAM use case, how are you going to bootstrap or start this problem with your initial data collection? Do you just put one truck out there, let it collect some data, do a manual labeling, and take it from there? Or?
Yeah. So we go onto the streets. We try to build a construction on a car that resembles a real garbage truck. So it needs to be at height to have a clear overview. So it was fun building that, and then we went into the street, we tossed some litter around, we had all our fractions with us. And then we start annotating, yeah, that's the boring stuff, but maybe later when they decide to move the POC to more productional environments and they want to do it for all those kind of fractions, we could work with third parties or something. So, but now we do the boring stuff ourselves.
I mean, dressing a car up as a garbage truck doesn't sound
Yeah,
as boring
that's
to
fun,
me.
but the annotating, that's
right.
less fun.
Okay, thanks for explaining. Thanks for being here.
Thank you.
Welcome back. We now have our Vision in the Loop academic use case concerning real-time monitoring and control in additive manufacturing. I have Brian Booth here from IPE, but we'll first watch the movie.
Hello, I'm Brian Booth, and let's talk about real-time monitoring in additive manufacturing. Now, when I talk about additive manufacturing, what I'm really referring to is the 3D printing of metal parts. And you can see an example of this on the left here, where we've laid down a layer of metal powder, and then a laser goes through it and melts the powder in the pattern of the object that we're trying to build. This process is repeated layer by layer until the full 3D object is printed. Now, the challenges here are, first of all, we have to be very precise, especially with the temperature of the metal. If the metal gets too cold, then the powder doesn't melt properly. But if the metal gets too hot, then you risk damaging the layers that you've already printed. And so this is a process that really needs to be monitored. Unfortunately, you can see from the video here that the 3D printers are very fast, and so we cannot monitor this with the human eye. So our goal here is to build an AI system that can do that monitoring for us. And conceptually, that AI system will look a little something like this. Our 3D printer will be paired with a very high-speed thermal camera, a camera that runs at least at 10,000 frames per second. And what links these two pieces of hardware is an AI module that will process videos from this thermal camera and output a signal that tells us how abnormal the printing process is. That signal can then be sent to the printer, and the printer can be adjusted to avoid causing further damage to the part that is being printed. So from an AI perspective, the challenge in getting a system like this going is really in the speed of the algorithms. We have to make some tough decisions about what algorithms we can use and how much of the video we can process. Not only that, but we also have to look at specialized hardware like GPUs and FPGAs in order to get the performance that we're looking for. Now, currently, this is research that's underway as part of the ICON Vision in the Loop project. We are able to collect high-speed video like what you see here on the left, or at least a slowed down version is what you see here. And we are able to process that video to produce a signal like what you see on the right here, where the higher the signal, the more likely we are in an abnormal printing state. The next step here is to take that signal and design control patterns that the printer can use to adjust its settings when an abnormal printing condition occurs. And our goal is to have that working by this time next year. Thank you.
All right, Brian, thanks for this wonderful introduction. Can you tell us a few words more about yourself?
Yes, so I am a researcher at the IMEC Image Processing and Interpretation Lab at Ghent University. My background is in the use of AI and computer vision in the industrial sector as well as the medical sector. And one of the projects we currently have is this Vision in the Loop project that involves multiple partners, most notably Flanders Make and Materialize. And we are looking at this 3D printing of metal parts. Yeah.
Okay. And that brings me to my first question. When you have the 3D printing of the metal parts and you're looking at what is a too high of a temperature and so on. How do you know what is too high of a temperature? Do you use explicit expert knowledge, or do you examine the pieces that you printed?
So we're sort of building on existing knowledge there that has come from the examination of parts that have already been printed. And what we can take advantage of is the fact that for at least 90% of the time, the printing process is in a normal state. So what we can say is that most of the data we're getting with our high-speed camera should be normal.
Mm-hmm.
We're only looking for things that are infrequent or rare that deviate from that norm. So that's the foundation upon which we're going to build our algorithms. Yeah.
You call it an advantage now, but it can also be difficult, right? If you're interested in the rare event, that's a tricky situation in itself.
It can be, but what we can take advantage of is the fact that we can get a good model of what the normal state is. And then what we can report is our deviations from that normal state, regardless of what exactly that deviation looks like.
And what methods are you using there?
So in that area, we're looking more at manifold learning or anomaly detection.
Mm-hmm.
In those methods, what we really want to do is, like I said, define a subset of the data that we consider to be normal data. And then we can measure for any video frames that are coming in, we can measure how far they are away from that subset.
Mm.
And that gives us a score that we can use to say how abnormal the printing process is at any given time.
Okay, so it's different from, for example, autoencoders, which are often also used to reconstruct normal behavior and then see the difference. But that wasn't applicable in your setting, I guess.
Well, actually, it can be. In fact, that's one of the things we're looking at, where we could use an autoencoder that does sort of a compression and then decompression step. And by doing that compression, you have to throw away some information.
Mm-hmm.
And what usually gets thrown away is the more rare parts of the data set. And so when we use the autoencoder later on and put our video data into it, what we get out of it should be something that looks normal, but is as close to the input as possible. So when we compare the input to the output, that should highlight or a big difference between those two would highlight some abnormal behavior.
Well, thanks for putting it in human terms, because I realized I was turning this into an academic interview and we're in AI4 Growth, so I should stay away from that.
Well.
When I see you that you're processing these videos, we're talking about images, are you using really the time series of the images? Do you, and again at risk of going a bit academic, are you putting any temporal information there where you
Yes, so we are actually looking at incorporating temporal information into the analysis. And one of the reasons we want to do that is because we want to see a stable printing process or stable temperature in the metal. So if we can look at how much that temperature varies over time, that would be a key feature to keep track of.
And I noticed in the video that you were showing that, if I understand correctly, the bright spots are the potential problematic areas. You would see those at where the line makes a little, like a curve and goes back up. Is that typical because the laser stopped there for a second, or how does that?
So it's
more complicated.
It's more complicated than that, but mainly if it gets too bright or too dark as well,
no.
Those are signs that something is going wrong. Things being too bright seems to be more of a problem, because if it's not hot enough, you can always go back and heat it up a little more. If it's too hot, then you end up with situations where you're causing damage to the part
that was already
in
printed,
previous layers, and then it's hard to really go back and correct that. So yeah, we are sort of looking for those bright spots, but at the same time, when you have too much heat on the metal, the energy starts to dig into the metal, and so you don't see it as brightness anymore because it's under the surface. And that's what makes this problem particularly challenging.
Yeah. So you cannot indeed just use the image, so you really need to examine the printed part afterwards.
Indeed.
And then given that you're in additive manufacturing or typically for small scale printing, how flexible is your solution for when you have to change something to the design? Do you have to retrain it for every design, or how does that work?
So what we're finding out through this research is that the design may influence the frequency with which abnormal behavior occurs. It might even change how that abnormal behavior looks on the camera. But the normal behavior stays relatively the same regardless of design. So, and that's the part that we're modeling. Now, it is likely the case that if you move to a different printer or a different metal, that you do have to sort of start more or less from scratch, because they will be quite different. Some transfer learning might be useful there. But we're also looking at algorithms where we learn on the fly. So for example, we'll print one layer, we'll take advantage of the fact that most of that layer should be okay, and build a model from that layer, and then use that in the next layer. Once the next layer is done, we can take that data and do a bit of retraining to improve the model and repeat and repeat. And this way we can get an AI model that is specific to the particular design and not to just any design that's placed on that printer.
Oh no, that's fascinating. So you can scale much more easily than if you can...
At least that's the hope, yes.
Indeed. And that brings me to, well, your background, you're in academia, but you are clearly industry focused. So how do you marry this challenge of building an asset that needs to advance the state of the art, but still deliver this robust value to customers?
That's always the $1 million question, isn't it? Or I guess the €1 million question. What we have to keep in mind is that there is that balance there, or that trade-off that has to be managed. So as long as all parties realize that, part of the time has to be in advancing state-of-the-art, part of the time can be in making sure that something is industry ready, then there's room to work together. At the same time, we do try to take advantage of the fact that whenever we're advancing the state-of-the-art, we have to compare to the existing state-of-the-art. So what we can do is set up a collaboration where the existing state-of-the-art is tested for industry readiness, while at the same time, in a parallel stream, we try to advance on that state-of-the-art. That way we get hopefully two solutions, at least one of them should hopefully work.
I understand then what, as you explained earlier, in the design of your solution, the practical usability, that's another benchmark, you would say, of what makes something state-of-the-art or not for the industrial application. So I guess that's another field that is that can help to distinguish or instill trust.
Indeed, and there is growing motivation on the academic side to see our work being used in industry, to be able to show that the work we're doing really matters in that sense. So we are open to that type of collaboration.
Okay, as evidenced by you being here. So thank you for your time today.
Yes, thank you, Mikhail.
Welcome back to our last presentation and short discussion before the online Q&A. I have here with me Ivo Coquet from Sumo Research Lab, who will be talking about data-efficient machine learning for engineering design.
Hi, hello. My name is Yves Coucat. I'm from the Sumo Research Cluster at Ghent University. In our group, we work on data efficient machine learning to solve various engineering design problems. In engineering design, you often work with simulation models, which have some inputs, design variables, and some outputs, like the quality and the cost of your design. And such a simulation model is used in many engineering domains, from automotive to electronics, to analyze and optimize your design. They have all one thing in common, each engineering domain. The simulation model is physics-based and thus very costly or time-consuming to run. One simulation can take from 30 minutes to hours or days. So if you need to run 100 simulations, it's not very feasible to do so. So what we do is we create an approximation of the simulation model using a circuit model. The circuit model is completely data driven, so it uses a limited amount of simulations because it's expensive, and it has the same inputs and outputs as the simulation model. The difference is that the circuit model itself will be cheap to evaluate, so it can be used instead of the simulation model. And the circuit model can then be used for optimization, design space exploration, but also to create a digital twin. So a digital twin, it's a digital copy of a physical system. So if you have a physical system like your manufacturing pipeline, it will generate a lot of data. And this data can be used to create a digital copy, a digital twin, which is a compact set of data efficient circuit models. And these circuit models, so this digital twin, can be used to feed back information to the physical system. So in order to real time optimize, calibrate, and fine tune a manufacturing pipeline, for instance. There are many use cases for circuit modeling, for instance, design space exploration or design optimization in this case. So here we want to design a textile antenna to track a firefighter in a building. The textile antenna is embedded in the clothing of the firefighter, so it has to be resistant to a lot of humidity. So even when it's wet, it should perform well. The problem is, of course, that the simulations are quite expensive of the textile antenna. And we want to find the optimal antenna parameters that work well, even when it's wet. So we want to find the length and the width of the antenna that performs well. So using circuit model, we find a better design in less simulations. So with circuit modeling, we find with only 71 simulations, we find a design that improves 34% over the reference design, which is obtained after months of trial and error and applying many optimization methods. Other methods like pattern search, simulated annealing, they perform worse than circuit modeling with the same number of simulations. There are many use cases of circuit modeling besides design optimization, and I'm hoping to discuss this use case in more detail and other use cases at the use case session in a couple of weeks. Thank you, and see you then.
Okay, Ivo, thanks for the pre-recorded introduction. Now, your own introduction.
Yeah, thanks for having me. So I'm Ivo. I'm from the IDLab research group at Ghent University. At IDLab, we have a circuit modeling lab cluster where we do research on data efficient machine learning. So in AI, you typically have lots of data. You have lots of images of cats and dogs that you want to recognize. But what we do is the other way around. We typically only have 10 to 100, maybe 500 data points. And specifically, we aim for engineering problems. So using in engineering problems, in engineering design, you typically work with physics-based simulations that are very expensive to compute. So one simulation can take from 20 minutes to a couple of weeks. Like the Ford Motor Company, they say one crash simulation takes about 40 hours to more than 100 hours. So if you need data, then you only are able to run the simulation 50 to 100 times.
Okay, I understand that in that sense the paradigm that you're working in is different. You don't have you're not in the big data world. You're then more scarce. I noticed on the Sumo website that there are papers referencing Sumo going back as far as 2010. Is that in part a reason why you are addressing these traditional problems, and you are not in the big data world as such?
Yeah, so the domain we are working it's very multidisciplinary. So we are coming from an engineering background, and then later machine learning came very popular 10 years ago, more or less. So we are having to follow different domains from engineering to machine learning, but also operational research is also doing similar things. So we have to be quite flexible and follow all those domains. In my presentation, I also talked about the textile antenna design, which is a combination of course, electrical engineering and the textile industry. But of course, the same methods can also be applied to other engineering domains, like mechanical engineering or to aerodynamics, for instance.
Yeah, as I understood, these textile antennas were even for firefighters when they're going inside buildings. Is this has it been leading to a practical application, or is this in the pre-study phase?
So we were involved a couple of years ago, and then it was not in a practical phase yet. But now I believe it has already been tested a couple of times, but we are not involved anymore in that project.
No, when you mentioned earlier that you are coming from the machine learning time and operation research, indeed, when I got to know your team a couple of months ago, I thought back about optimal experimental design and so on, so I can see the roots where you're coming from. But at the same time, in your presentation, you also mentioned digital twins. So you're clearly keeping this asset or this technology up to date, or you're keeping track of whatever is happening. Can you explain a bit more how you tackle these problems, how you solve this?
We really have to follow, like I mentioned, really different domains and really pick up on the paradigms that are changing, like the digital twins that have come into play, and then see if there is some overlap with our research or not. Our research is data efficient modeling. In digital twin, you have several fields, of course. You can do it completely data-based, which has no overlap with our own research field. But you can also create models as a digital twin. And then, of course, there is a lot of overlap if the data is expensive, because the data can also be generated from sensors, which generates a lot of data. So there is some differences, but there is also some overlap that we always have to follow and keep an eye on.
Okay, and when I hear you talk about data-driven models and physical models, I immediately think of another trending topic, hybrid AI. There's overlap with what you are doing as well, of course. Are you collaborating with any colleagues there?
We do have some collaboration with Guillaume, who works at Ghent University on hybrid AI, but at the moment it's not our primary research focus. In hybrid AI, you really want to combine the physical modeling and the data-based modeling. So there are some collaborations indeed.
Okay. Okay, but you're talking about what you are doing, and you are building this or maintaining the Sumo asset for now more than 10 years. How do you do that in an academic field where you have a churn of researchers, PhD researchers come and go? How do you maintain the stability?
Yeah, I think it's important to keep the focus. Like you mentioned, the paradigms are constantly changing, but our focus always has been the data efficient part with expensive physics-based simulations. So that's one thing. So each researcher or PhD student can build on the work of the previous students. That's one thing. And the second thing is we always try to implement our research in toolboxes, in software. Some of them are publicly available for engineering companies. Some of them are more internal, our most recent research. And that also helps in really keeping up to date, so that the new students can really build on the methods and the software that previous PhD students have built maybe 5 years ago.
Yeah, I saw indeed that you offer this dual licensing for the Sumo, or I don't know if that's the right term. We have academic and for-profit licenses. I'm sure that also helps with maintaining attraction around or attention from around the world.
Yeah, indeed. So the Sumo Toolbox software is available on our website among some other software packages, and that also helps to maintain a network of both academic and industrial relations. So we have, for instance, we had a project with Toyota Motor Corporation, a couple of projects there, but also Intel is, for instance, is using that toolbox. So it's really helpful to really maintain a close relationship with industry to see what the needs are and the requirements. So we can really fine tune our research on what's needed now in industry.
Okay, well, industry partners, you heard Ivo. Get in touch. Thank you for today.
Yeah, thanks for having me.
Okay, that was it for the pre-recorded part of today's AI for Growth session. I'd like to thank the speakers again for being here today and for their preparation work in submitting the videos. We hope you've all been collecting questions in the meantime, because now we're going to go over to the Q&A session. This will be partly in Teams, partly on YouTube. We have our partners ready to answer any questions you may have. See you in a few seconds.
Okay, thank you, Maarten. So apparently we will start in a couple of seconds with the Q&A session here in Ghent on the topics we have just watched on the YouTube live stream. I wait a little time so that people can pop in, the partners of AI for Growth, to participate to this Q&A. We will raise the questions in order of the presentation's appearance. So first with transition, then with Delaware, then with, Ordina, we can share some reflections, but they are not present to answer the questions. Fourth, we go to EMIC on the 3D printing. And fifth, we go to ID Lab on the digital twin models. I see some more people popping in. Welcome to this question session. Let's give it a little bit more time. Let me check the number of participants. Okay. Good. So we will start with the first question for transition. While more people are popping up, I see also Bart there. Hi Bart, welcome.
Hello.
Hey, I just recall we will start with questions in the order of the different presentations. So let's start with transition. Anyone who has a question for Vincent?
Maybe if I could. Hey, Vincent, and good to have been able to connect behind the scenes here.
Indeed.
I was wondering, could you expand a little bit on the type of content, on what type of data are you actually building your models?
Yeah, so we call it open big data. So we use mostly only publicly available data. Basically, what we do is we look at trend life cycles. So a typical S-curve, I think I should draw it like that. And we categorize specific data sources onto these life cycles. To give you an idea from the type of data sources that we scrape, it's about research publications, university publications, papers, patent databases, startup news, startup databases, VC funding news, but also sector-specific blogs, sector-specific news, consumer blogs, mass media news, even social if we want. In some cases, we look at Google search to get the last point of what are people searching for. So really broad, in a really broad sense, all kinds of valuable news sources that we can monitor. Yeah.
And you do that in multiple languages, or?
Yeah, so our models are generic. They're trained project-based in a specific language. So today We do English, French, Portuguese, and that's about it. But whenever we see a project and we get the question to source different languages, we just train our models to learn that language in that sense. So technically, there is no option. It's just a little bit more effort the first time that we need to put in there.
All right, thank you.
Okay, thank you, Jan. Anyone else having a question for Vincent, Wouter, or Peter, or someone else?
Not from my side for the moment.
Okay, then I add one. So, Vincent, you explained a bit on how you zoom into different sectors, basically looking into industry or medical. But I'm wondering, of course, if you do the opposite, if you look into the aggregate of trends, can you derive something for the impact on the entire, say, society, on our jobs, our environment, and so on? Any comments?
Yeah, so how we apply this research is really from more foresight methodologies, so trend watching methodologies, trend research methodologies, and that's really about looking top to bottom. So mega trends impacting macro trends, impacting specific micro trends in sectors. We're not solely linked to looking at a specific sector. We can even look at what's going on in society as a whole. We can then even zoom in on different regions in the world. What's going on in society in China is not the same as what's going on in Europe, for instance. And then we also are able to monitor horizontals, big themes like mobility, energy efficiency, sustainability, climate change, and all these kind of big themes not only impact businesses but also society and governments. So for us, there really, the approach that we apply, there really is no difference and what we can scan or how we monitor our or filter our scopes. It's just a context for us, and doesn't matter what context that is.
Okay, and finally, if I have a certain interest as a non-customer, so to say, should I watch certain channels? Do you make certain things megatrends public, or how does that work?
Well, today we're really heavily into our projects that we know that we can do a lot more with what we do from a marketing perspective. So there isn't much that you can follow. You can follow our LinkedIn page, of course, and there you get the latest news, and we post a couple of reports that we sometimes give away for free and stuff like that. But that's about it at this point from a marketing perspective or what you can follow from us.
Okay, very good. Anyone from the other presenters who has a question for Vincent? Okay, then let's go to, thank you, Vincent. Let's go to Delaware on the tagging factory. I first give the word to the audience. Any questions?
Why Delaware, Kevin?
What do you mean?
Why is the name Delaware.ai?
You mean the company name?
Yes.
Because Delaware AI is part of the broader Delaware company, where the IT consulting company. From where the name exactly comes, it's not related to the United States state. Probably it's somewhere between one of the founders is called Delare, and then you have software, so probably it's a mix between those. That's what I've been told, but it's a little bit of a myth within the company as well.
So if you would have to build the solution for image tagging in a completely different corpus of images, what are the minimum requirements and how long would it take?
Well, yeah, that's a very broad question and yeah, not so easy to answer. We say, depending on the scope, we say at least give us 100 labeled images if you want to look at a specific tag. If you don't have that many images available, we can always help you out and see if we can transform the existing ones a little bit so that we can still have a minimal requirement and then start with testing from there. but it really depends on how hard the label that you require, how hard it is to detect on an image. So yeah, it's not really easy to answer that. It's case by case.
And how quickly is the tagging going?
Well, yeah, I think the initial case was to replace human labeling. So as you can imagine, if you compare it with that, then quick. So yeah, it's fully automated. So it's in a matter of.
And the quality control
seconds, I guess. You just broke up. You said it's in a matter of
seconds, indeed. Seconds.
Thank you.
And reviewing the automatic pipeline, that process, how smooth did that go? How many false starts did you have, so to say?
Well, to be honest, the pre-trained models are quite stable, so that's not really causing too much issues. The biggest problems are coming from poor data quality, so poor image qualities, where depending on what type of images we're working with, that are these resulting in some either strange tags popping up or no tags at all, because there wasn't able to find anything. But and since we mainly are working with product related images, in most cases they have a white or a neutral background, which is most optimal, because then the focus is on the product, and then most of the or all of the labels are product related. So that's the most optimal case.
Indeed, because one of the questions I prepared but didn't get around to asking was how does what happens if you have suddenly a new image supplier in the pipeline, or a new subcontractor for the company?
Yeah, well, like I said, background is part of the image, so we get labels of that one as well. But the most important thing is that the tagging factory, like I said during our talk, is it generates a new data set. So the labels are new information that you can start working with. And if you know and have a more or less standardized background, whether it's white or no or noisy, it doesn't really matter. Then the same text and labels will be popping up, which you can then filter out afterwards. And this is something that we have to do in every case, because since there are so many tags available right out of the box, that definitely, regardless of your use case, you will have some cases or some labels that are not relevant for you. So these we filter out after the labeling process has been done.
Yeah, and I guess that pre-processing to do standardization is also part of the pipeline anyways. Yeah. Thanks.
I do have a question, Kevin. I'm Peter from Savacol. You mentioned that you started with state-of-the-art models from Microsoft and Google and so on.
Mm-hmm.
Can you tell how much did you need to modify them to get to your custom developed models?
Well, we separate those. So we really the tagging factory is really a combination of models in parallel, where we put the image through the different types of models that we have available. Some of them, like I said, the pre-trained models, so these deliver a number of specific tags. But we also have built our own code that is mainly oriented on use cases that we had in the past for our customers, because that's the nice thing about the tagging factory is the more use cases that we have, the more custom requirements that we get, the smarter the tagging factory becomes, because we can reuse these models to deliver these labels in the future then as well. And we had a use case, for instance, that colors played an important role, and that there was some difficulties because, like I mentioned, with the black T-shirts, so we created then some custom model ourselves that focuses specifically on these colors, and so these are then added, and then once you have the output of the different models, all the labels are put into one file, and that's then the end result.
Okay, thanks.
Thank you. Any final question for Kevin?
Yeah, I
No?
guess I have one.
Sure.
So Kevin, how do your models deal with a black and blue dress that is also somehow a white and gold dress?
Yeah. Well, that's actually one of the use cases that our tagging factory ID was coming from. So, like I mentioned during our talk, I talked about black T-shirts. So, what was in that situation, the labels that were being added to the product manually were coming from the production process. So, if you would use a single black thread to your T-shirt, then that T-shirt would receive the label black because at least some sort of black color was being used. And of course, as you can imagine, if you then search for a black T-shirt, in the top results there was T-shirts with some black text on it, but not really what you would expect as looking for a black T-shirt. That was one of the cases that we started from, and for that we developed a computer vision model that scans the whole picture and reviews the percentages or what colors are present, and then calculates the percentages of the colors that are present on that image. And especially if you have a white background, then we assume that you don't present as a white T-shirt, then we can calculate how much blue or yellow or gold or whatever the color it is present on the image and on the product. And by using these percentages, we can then improve the label quality. So we still would add to a T-shirt with a black text the label black, but it would get a much lower percentage or weight score compared to a fully black T-shirt.
Okay. Thank you. Then I think we can go to your topic, Brian, on the 3D printing. And yeah, let's see if there are any questions for you. If not, I can open the floor with a question. So Brian, you mentioned the link to big companies like Materialize. So I was wondering in which stage your project is, meaning is it still more in a lab, or do you already start to apply it in production kind of environments with Materialize or other partners?
So at the moment, we're sort of between those two environments. So we're finishing up the lab work in the next month and a half, at which point we will be bringing it into the research machines at Materialize and Flanders Make to actually test kind of in the loop, as we call it. So the goal is to have the proof of concept working in the loop in those machines by this time next year.
Okay, interesting.
Thank you.
And I think you were mainly working with metals. Would your approach also work with other materials that are being 3D printed, or is it really focusing on heat detection?
So it could work for printers that use a laser to melt powder. So this is not just metals, but plastics also use the same sort of format. Again, yeah, you would have to train separately on the different materials, but the general concept can apply. Yeah. If you're looking at other 3D printers like the FDM printers, which sort of melt the plastic within a nozzle and sort of draws with it, that's a completely different area of application. So you need something different there.
As would be organic material.
Probably, yes.
I wonder what Bart is referring to, indeed. When you say lasers, is it because of the high speed of a laser compared to a regular 3D printer? Because you could also consider the nozzle of a plastic printer also has a temperature that might be monitored and so on. So because you make it sound as if those are drastically different applications.
Well, in my mind, I'm thinking that if you're looking at an FDM printer where you're sort of squirting out the plastic into a shape, I'm wondering, first of all, it's definitely a slower printer than you have with the laser printer. So you can really sort of monitor it by eye almost. The other thing that is that for a FDM printer like that, I'm not sure if the camera is really the best option for monitoring that process. Maybe an internal sensor would be better.
No, indeed, but you are using the camera only because you have no way to directly measure the temperature. And
Exactly.
if you have a printing nozzle that could, where the temperature is even set, in that sense, the images are a way to obtain information. And if you could get the information directly, but yeah,
Yes.
of course, it puts whole different constraints on the solving algorithm. You're working on a much harder high-speed solution in that sense.
Indeed, yeah, that's right.
Okay. Thank you, Brian. Any more
Thank you.
questions for Brian? No, then we go to the last topic with Ivo from ID Lab on the digital twins. Anyone who wants to put a question here? Jan? Sorry, Bart. Bart, go ahead.
Bart was saying goodbye, I'm sorry.
Okay. Michael, you were also saying goodbye?
No, I wasn't thinking clearly and I was waving goodbye to Bart, which I shouldn't have done.
No problem. So if not anyone else, a short question from my side, Ivo. So you explained on the digital twins, which is a widely known concept, but in your, say, optimizations with the circuit models, how generic is that? Do you see certain areas of application where you feel it will work well and other areas where it will work less? Any comment?
Yeah, maybe first of all, the digital twin, it's quite a generic concept, so it's not really tied to any domain. It's just, replicating a life cycle of a product or a system. So it can be applied from engineering to biology. But mostly it's applied these times in the Internet of Things, like smart cities, or in manufacturing to guide, to fine-tune a manufacturing pipeline, for instance. So it's not really tied to a domain, but it can be applied, maybe even in the future, a digital twin of a person, for instance, just to follow that person digitally. In healthcare. For our use cases, for my use case, we specifically focus, of course, on the time-consuming simulations, and these are very useful in the engineering, and we particularly focus on the electrical engineering problems. But we have also applied it to mechanical, to aerodynamics, and so on. And even up till process optimization. So in that case, we work with measurements to optimize a certain process.
Okay, thank you. Any other question for Ivo? No, if not, then we can close on this session. Thanks again to all presenters and to all people who contributed. And stay tuned, we will have another session on health and medical in the May timeframe. Thanks again and bye from Ghent.
Thank you, bye-bye.